Basically how we design an aircraft right now is we say, okay, where are we going to fly it most often, and let's design around those parameters. But in fact what happens is you have variations in weather, atmosphere, locations that you're flying, and a morphing wing really allows you to adapt to those differences and the environmental parameters.
People believe that the traditional plane wing is rigid. It's not. Actually, when you sit in the plane and you're looking through the window, you realize that the wing is fluttering. Secondly, when you're looking at a bird, you realize the bird wing are really elastic. What a morphing wing is trying to do is trying to use some of the characteristics of the wings existing today and what a bird does to adapt, to adjust the shape of the wing so that it's going to improve the efficiency and have a better flight. My name is Mircea Teodorescu and I'm in the Computer Engineering Department at University of California, Santa Cruz. Everything started with UARC sponsoring a PhD student in our group to work over the summer with one of the groups at NASA which was interested in morphing wing. We got a very good set of results which led eventually to 1 full year being sponsored by UARC and later to a couple of other projects that we gained together with colleagues at NASA. What we have done was to improve the algorithms and to start developing new algorithms of controlling the behavior of the wing, understanding the physics which make the wing behave a little bit better, and hopefully together we are developing a new generation of morphing wing. Some of the challenges in developing morphing wings are mitigating between the elasticity of the wing and the controls, the algorithms we are designing to morph the wing in a certain direction, and at the end of the day having a correct prediction. So the modeling suddenly becomes really important.
My name is Nick Kramer, and I am a 5th-year PhD student in Computer Engineering Department at the University of California, Santa Cruz. My research is primarily in modeling and simulation, so I do a lot of aerodynamic simulations, looking at the aeroelastic effects. Now we've started moving into building these test rigs, and we're moving into the area where we can check to see that our assumptions are correct for the models. For example, is the airfoil the same shape it was when we twisted it? Well, it's twisted before it's twisted. In order to address the challenges of the morphing wing, I'm really looking at the controlling aspects of it. So how fast you're moving them, when you're moving it, and how to really sense the environment and interpret what's going on.
Initial seed funding provided by UARC allowed us to start our collaboration with NASA, which meanwhile has evolved into 2 other collaborations. One, it's a NASA grant that we have with the colleagues at NASA, and the other one, it's an SBIR funded also by NASA, but it's between us and the commercial company Aurora. The first phase, SBIR, is going to allow us to create a prototype morphing wing flying UAV. And if we are successful, this should lead to much larger funding also through SBIR, which to build a real type aircraft.
In the future, what I envision is, specifically with the Aurora project, is something where on a fixed wing UAV that you might want to do some sort of surveillance with, be it agriculture or construction industry, that you'll be able to actually stay at level flight while still maintaining some yawing motion, so you'll be able to stay within a single plane so that you can get the best image possible while still being able to rotate and move around actively. And that way you can really enhance the visual aspects of that work that you're attempting to do.